Hello guys, welcome to this lesson. In this lesson, we are coming to learn how to construct truth tables using the basic logical operators. Before we begin our lesson, I'm urging all of us to visit our website iworldtech.com for more videos. So let's get started, okay? So in our previous lesson, we studied the 5 basic logical operators. That is, we have the negation, we have the AND operator, that is conjunction, the OR operator, disjunction, we have the implication, and we have the by implication, okay? So before you construct a truth table, you must know the number of possible outcomes of the truth table, okay? So the number of outcomes, number of outcome is given by the relation 2 exponents, and we have 2 here because there are 2 possible outcomes, either true or false, okay? But this N stands for the number of statements, okay? So when you have 2 statements, you are going to get 4 outcomes. When you have 3 statements, you are going to get 8 outcomes, okay? And many more, okay? So this is the first thing you must keep in mind, okay? So let's begin with the negation. Okay, let's begin with the negation. That is the not operator. This not operator can only be operated on a simple statement. Okay, so when we have a simple statement P, okay, so this means that the number of outcomes is going to be what? 2 exponent 1. Since we have just one statement, okay, so the number of outcomes is what? Is 2. Okay, so the not operator, that is not P, is given by this. Okay, so we have true, false, that is for P. And not P, that's the negation of true. Okay, the negation of true is false and vice versa. Okay, so not P, so if it is true, it becomes what? False. The negation of false is what? Is true. Okay, so that is for the not operator or the negation. Now the next logical operator is AND. Okay, the AND operator. Okay, it is also, this is what also called logical conjunction, and it is what? A binary operator. Okay, so we can only perform this operator on 2 or more statements. Okay, so let's assume you have 2 statements P and Q. Okay, so it implies that the number of possible outcomes will be what? 2 exponent 2, that is 4. Okay, so let's construct the truth table. Before we construct the truth table, there is a principle that is attached to it. This operator only returns true if both statements P and Q are true. If P is true and Q is false, it will return false. If P is false and Q is true, it will return false. This operator only returns true if and only if both statements are true. Okay, so let's construct our truth table. We have P, then we have Q, then we have P and Q. Okay, so we have 4 outcomes. Okay, so 4 out of 4, you partition it, okay, into true, true, false, false. Okay, under the P, so it becomes true, true, false, false. Then you also partition this one into true, false, true, false. I said earlier that this operator only returns true if both statements are true. Okay, so true, true returns true, true, false returns false, false, true is false, false, false is obviously false. Okay, so there is a trick attached to this one. Let me write it here. Okay, so you let true stand for 1, false stand for 0, and this AND operator stands for multiplication. Okay, so true, true, that is true and true stand for, that is 1 times 1. 1 times 1 is 1. That's why we have true here. And then true and false, that is 1 times 0 is always 0. That's why we have false here. False and true, that is 0 times 1 is 0. That's why we have false here. And 0 times 0 is obviously 0. That's why we have false here. So that is for the AND operator. Now let's move on to the next operator. Okay, the next operator is OR operator. OR operator. So that is OR operator. Okay, so let's consider two statements P and Q. Okay, so this OR operator only returns true if any of the statements are true or both of them. Okay, so if P or Q is true, this operator returns true, or if both P and Q are true, this operator returns true. Okay, so this operator only returns false if both statements are false. Okay, so let's construct a table for it. Okay, so we have P, we have Q, then we have P or Q. Okay, so true, true, false, false, true, false, true, false. Okay, so true or true returns true, true or false returns true, false or true returns true, false or false returns false. Okay, this one too, there is a trick. Okay, there is a trick. So as usual, true stand for 1, false stand for 0, all stand for addition. Okay, so before you can apply this trick, you must know that true or true is always true. Okay, true or true is always true. Then true, that is 1, or false, 1 plus 0 is 1, that is true, that's why you obtain true here. Then false or true, 0 plus 1 is 1, that's why you had true here. Then true or true is, false or false is false, that is 0 plus 0 is equal to 0, that's why we had false here. So this is how we construct the truth table using the OR operator. Now, before we move on to the next operator, there is another operator called exclusive OR. Exclusive OR. Okay, in the engineers will call it XOR. Okay, that is XOR, or this one, that is exclusive OR. This operator functions as the OR operator, but the only difference is that in this operator, this operator only returns true if any of the statements are true. If both statements are true, this operator returns false, unlike the OR operator. Okay, so when you have two statements P, Q, then P exclusive OR Q. Okay, so as you have true, true, false, false, true, false, true, false. Okay, so this operator functions as the OR, but the only difference is that this operator returns false if both statements are true. Okay, so true or true exclusive or true returns false, that's the only difference. Okay, then true or false returns true, false true is true, false false is obviously false. Okay, that's for the exclusive OR operator. Okay, the next logical operator is implication. Okay, logical implication. Logical implication. Okay, so when you have two statements P and Q, and you perform operation, this operator on it becomes P implies Q. Okay, so when you have this logical expression, this P is called the hypothesis. This P is called the hypothesis, and this Q is called the conclusion. Okay, P is the hypothesis and Q is the conclusion. Okay, so when you have this logical statement, this operator returns true for all values. Okay, it always returns true except if the hypothesis is true and the conclusion is false. That one, it will return false. Other than that, it returns true. Okay, so this operator returns true for all values or for all logical expressions except if the hypothesis is true and the conclusion is false. Okay, so let's construct a truth table for this. We have P, we have Q, then we have P implies Q. Okay, so true, true, false, false, true, false, true, false. Okay, so true, true returns true, true, false. Here our P is the hypothesis and our Q is the conclusion. Okay, so since the hypothesis is true and the conclusion is false, it implies that this operator will return false. Okay, false true returns true, false false returns true. Okay, that is the logical implication. Okay, so let's move on to the last logical operator known as the by implication. By implication, that is the if statement. Okay, the if and only if statement. Okay, so when you have two statements, P and Q. Okay, so when you perform this operator on this, that is P if and only if Q, this logical expression or this operator returns true if both of P and both P and Q are what? Are true or false. Okay, so if P is true and Q is true, this operator returns true. If P is false and Q is false, this operator also returns true. But if any of them, or if P is true and Q is false, the operator returns false. If P is false and Q is true, the operator returns false. Okay, so that's how the by implication works. Okay, so we have P, we have Q, then we have P if and only if Q. We have true, true, false, false, true, false, true, false. Okay, so we have true, true here. So this operator returns true. True, false is false. False. False, true is false. False, false is true. Okay, both statements are true, returns true. Both statements are false, so this operator returns false. Okay, this operator. Okay, so that's how the by implication works. Thank you.